Good evening, afternoon, and morning, everyone, and welcome to today's Ask the Expert session on key steps towards circularity in the built environment with Martha Lewis, Head of Materials at Henning Larsen's Architects. And just to get you all engaged, would you please take a moment and in the chat function, pop in where you're signing in from. And this session is the first in a series of deep dives that continue on from the discussions that we were having at the FM Symposium, Ask the Experts, where we were focusing on beyond net neutral buildings. And we were looking at how we can take steps towards looking beyond just mitigating the impacts of buildings on the built environment and taking steps towards having them have a net positive impact on the built environment. And one of our fantastic subject matter experts looking at circularity, materials passports, buildings as a materials banks, and the composition of materials that shape our built environment, Martha Lewis. She was there providing some fantastic insights, and I'm so happy to have her with us today so she could share her work and all the fantastic work that's being done on driving circularity in the built environment. So Martha, without further ado, I'd like to have you give us a view on all the fantastic work that you're doing in driving circularity in the built environment.
Thanks so much, Jeff. Thanks for the invitation, and thanks for the lovely introduction here. I will share my screen. And so you should be seeing a full presentation mode now. Do I have a go?
We can see you're ready to go.
Great. I have a talk all prepared that is primarily focusing on digital product passports and on building passports, and how is it that we extend the possibility for circularity in the built environment. And in order to launch this, I really do need to just simply start on the big picture and look at the perspective, because we are all operating in a context that is a little bit hyper right now, reading the newspapers, getting the news from various different agencies, government agencies, from international agencies, and from very specifically from the UN. The UN describes this moment in time as a triple planetary crisis. So I actually want to start with this just to position some of these really relevant considerations we are having about why is it we need to change the way we're working in the built environment, and why is it we need to be working with new tools and with new considerations by starting on the global level. And all of you are very aware of the construction sector's contribution to the CO2 emissions. We are in the midst of a climate crisis. That's one of the three crises that the UN Environmental Panel defines. And one of the very important aspects of that is that the materials, and construction materials specifically, contribute to 11% of all of global CO2 emissions. So we really do need to find a way to not be producing so many new materials, but to find a way to successfully reuse materials that already have been produced. The second crisis is the loss of biodiversity crisis. And here I just mention it because it is driving some of our decisions on the building selection of materials. However, I'm not going to dwell on it today. I just want to put it out on the table and move on to the pollution crisis, which is defined in two parts. One is the chemical crisis, and the other is a waste crisis. So the pollution is a combination of this extraordinarily large consumption of chemicals that are these human pressures are really putting the globe under excessive pressure, and we're really seeing it. For example, in reports that show that we all have plastic in our blood. Things like this are very unnerving, and we also need to look at the built environment to say, okay, what is it that we're doing in the built environment? Where can we make some positive change here? The chemical issue is highly relevant for the built environment because the construction sector consumes 28% of global chemical production. And the construction sector is the #1 end market for global chemical production. So if we can make some changes there, particularly with hazardous substances, we would be making very positive changes. In Denmark, for example, data from 2012 showed that nearly 14,500 tons of hazardous chemicals were used in Danish building products. And the data follows the global trend. In 2017, we had a 58% increase, so we're up at 20,000 tons of hazardous substances that were actually used in Danish building products. A Danish EPA study looked at where are these problematic substances coming from. They identified 48 different hazardous chemicals used in Danish building products. And because of our focus on we need to be reusing products, this study was looking very specifically at which of these hazardous substances are problematic at the end of life. And they identified that 50% or 24 substances are actually problematic at the end of life phases. So these are really interesting studies that point very specifically to what we need to be looking at in order to be smarter about the way we make our decisions initially, but also about how we reuse our building materials and our resources in order to avoid producing new building products. If we think that our certification systems are doing the screening to keep hazardous substances out, they're not. Based on a Nordic study looking at Denmark, Finland, Norway, and Sweden, only Sweden has written their certification systems so that they're actually screening for the hazardous substances that are in use. The other 3 countries are less effective. The gray bar shows the total amount of hazardous chemicals in use in 2017. And the orange shows what the national certification system is actually screening for. So unfortunately, a very small overlap there. This is quite problematic for what's coming into our buildings. And as I said before, the other aspect of the pollution crisis is construction waste. We're looking at huge quantities. The estimation for 2025 is that 1.1 billion tons of construction waste will be seen annually. And we need to readjust. We need to begin to look at this waste that's on the picture here and think of it not as waste, but as our future potential resources. Another aspect of our use of resources and our material product selection is a looming resource scarcity crisis. We're beginning to see this with concrete, with shortages of sand which is quite necessary to make concrete. But between sand shortages, but also very specific shortages that are in the offing for the elements that are quite essential for building products, and very specifically for production of electronic building products. For example, we're seeing shortages coming up for nickel, for copper, for zinc, for chromium, for tin, for silicon, and for mercury. All of these 7 are quite relevant for development of high-tech building systems and electronic building products, as well as some more low-tech metals in building products. So between all of this is the global perspective. And to sum it up, we're simply stepping beyond a safe operating space for definition of planetary boundaries. We're operating beyond these safe operating space. And that is summing it up with the first 3 planetary boundaries. We have loss of biodiversity, we have climate change, and we also have novel entities. And these 3 novel entities is chemicals and plastics. But these 3 areas are highly relevant for the building industry. So if we can make some progress on these 3 by working in new ways and thinking in much more circular ways, then we've made some small incremental changes that would be quite successful for a net positive future here. It does mean, and again, I'm head of materials, so this is really quite relevant for my daily work. It means that the materials decisions that we make now in our design projects are very critical. And very specifically, circularity, resource reuse is simply imperative for our future construction and for our future design decisions. So of all this multitude of crises that our sector faces, a few of these could be aided with a digital material passport. So I move on here to a discussion of what is a material passport, what do I mean by that? And then I'll address what is the difference between a material passport and a building passport. These are two levels of data collection. And the material passport is simply a way to support this circular economy, a way to work less linearly with a take, make, waste approach, but a way to give informed information linked to products so that we can, with this data supports their actual reuse, and that we can use construction materials in a circular way and thereby combat climate change, hold down those CO2 emissions, and hold down the overburdening of our planet. This is also part of the EU's new Circular Economy Action Plan, very specifically the bullet point in red at the Circular Economy Action Plan calls for the digitalization of product information, and very specifically for working with digital passports, and also with tagging and watermarking systems on actual products so that it's linked to the data that's in digital passports. And essentially we know what this is because this is what we have on our cosmetics, and we also have it on our food internationally. We have the labels. We're looking for labels for building products. So a declaration that contains some very useful information, and that's also digitalized. And we're looking for a way to work with more transparency and also more traceability in building products. I am speaking from Copenhagen, so the work that I'm doing is oriented towards the EU market and refers to EU standards. That this material passport should contain chemical content and resource potential, and that it also is a platform for sharing references to existing documentation, for example, a building product certifications, or whether it has environmental product declaration, also called an EPD. This is a voluntary declaration, and it's not a certification. Very important to understand that. It's something that a manufacturer will put out there and declare what is in their product. It needs to be digitalized on a decentralized system so that there's not only one point of management, data management here, but that the data could live on a manufacturer's website as well. We're looking at using the open data format in development of this data exchange, and that this data essentially becomes the basis for establishing value in a building. First on the product level, but then with the accumulation of data from various different building products, that then you have the profile of a building's value, its potential future value. So we're working very specifically in Denmark with the development of a passport that contains, for example, manufacturer's information and product information. Very specifically, this product content is highly relevant. Also addressing what kinds of chemicals are used in the production phase. Packaging, just like food, gives you information about, is this packaging recyclable? It'd be very handy to know that on a construction site when you receive a shipment. Is this a pallet that can be sent back? Is this a packaging that has a second life? Is this packaging that has a recycled value? And then we have these are the 8 sections in this passport. We have the 6th section, which includes information about recommendations for on-site. Does the product need to be stored so that it is in a humidity controlled area, for example, or it needs to be protected from rain, etc. How long can it be stored? That kind of information for buildings, relevant for building site. And then number 7 is maintenance and operation requirements and guidelines, as well as indoor climate performance information. And finally, again, in bold here, the 2 points that are highly valuable and very necessary for a material passport. The final point here is the resource potential, looking very specifically at what is the value of this and how do we access this product at the end of its life. I'm going to dive into the 2 bold points here, the essential part of the material passport. And we have a identification of the components that make up the product. Perhaps there is just one component, but there could also be multiple components. And for each component, we need to know what is the content of that component, including perhaps part of the content is recycled or it's a direct reuse. Also very informative to know that information. I'd like to know what percentage of the whole does this component represent? And then very specifically, what is the chemical content expressed in CAS numbers? And associated with those CAS numbers, are there any H phrases? We have this in safety data sheets today, but safety data sheets only cover a small portion of the materials that are used on a building site, and they don't cover building articles. So we don't have this kind of information when we get longer into the use phase. So we don't have this information accessible for facility management, for example. What are the H phases that are in these building articles? Could be very useful information for the next life. And then where does the product come from, the country of origin? Under resource potential, we ask questions and gather data about taking this product out of the building, disassembly, selective demolition. Is there a guideline for how to remove the product from its location in a building? Once you have it out, how do you separate it into parts, if it's a component, for example? Is there hazardous waste that is part of this component? What is the reuse potential? A definition of that. What is the recycling potential? A definition of that. And also simply a guideline, how to. What's the next step? Trying to make this very feasible information, so to make the circularity much more feasible and realistic that it actually happens. For example, including very specific links to take-back agreements is very helpful here. Links to the manufacturer who has made agreements with the client on take-back arrangements. How do you actually, at the end of life, then activate this take-back agreement? If it's a leasing agreement, what's the data that we need, or the link, or who do we approach with this leasing agreement? Should there be one for the product? Is there skip database registration? That's also quite interesting in terms of the hazardous waste. If there are hazardous substances associated with the product, then there is perhaps a recommendation for parts of the product need to be treated as hazardous waste at the end of life. And then the very important identification tagging on the physical product so that you can link into the digital data through either QR codes or through some kind of a scanning possibility. So just in summary on this data that we need to have, the digitalized material passport, in-depth knowledge of the composition of construction products is a prerequisite to be able to circulate. You can't safely process what you do not know. So, moving on, a little bit more information about the digitalization of the pass, because this is quite essential. We're way beyond the era where we can work with PDFs and have this be useful data. We need to be moving forward with digitalization. And the thought of this is that it is the manufacturer who establishes the original data set by filling out the open data format, the templates, and providing the information about the product. And that this then is set into, as I show on the screen, a circular exchange where this information is then used by designers, by people making product selection choices, so that they have additional and more optimized knowledge about material content and also about the materials or the product's future potential, so that you can actually be making choices that and prioritizing products that do have a very positive future potential, as opposed to products that are going to end in landfills or products that have high hazardous content. So the intent of a material passport is really twofold, so that you have optimization in the selection process in the planning phases, but you also have the optimization of like ensuring that the product comes into a reuse loop as opposed to ending on a landfill. The designers, if I continue this loop, the designer can then plug this open data set into a BIM model, or the contractor, depending on whether this is design build, can be making selection and plugging the ultimately chosen product into and its data into the BIM model or into an IFC model, which at the end of construction is then passed along into a facility management and needs to be aligned with, on a project level, aligned with what are the digital tools that facility management is working with, and how can this data then be accessible for facility management. This is where we have an interactive material passport, and it moves from being a passport for a specific product on a generic level to a passport for this particular product in this particular building, where the option would be there to add the life cycle or the lifetime information. This particular gypsum board was painted. It was painted 4 times through the life of this building. Or we removed this product and we replaced it with a new product. So that kinds of information, this historic data, aligned with the facility management's digital tools, could be quite useful then for keeping track of the history of building products in a particular project. And then all of this data is supposed to, ideally, support the end-of-life scenario, so that when you renovate a particular section of a building, that then you have better knowledge about what to do with this product. What is its next life? How can we send it along its path? Do we have a take-back agreement? Do we send it back to the manufacturers? If so, how do we do that? Is this product geared to be sent to certain reuse organizations in order to upcycle and send into the loops again? So this is all simply data that should support this circular understanding, and not just understanding, but actualization, I should say, of building products. A lot of people confuse the material pass with environmental product declarations, also called for short EPDs. And just to make this really clear, the EPD has environmental impacts. This is where you go to find your global warming potential, and this is where you go to find other environmental impacts and perhaps the energy profile of the life cycle impacts of a material. However, the material pass contains a lot of things that are not in an EPD. For example, the chemical content and a positive list for future reference of ingredients in the material. It also contains maintenance and operation information, which is not in an EPD. And it defines this guideline for the resource potential. Again, an EPD will address theoretic future life definitions, or what happens at the end of life. These the end of life scenarios, they're defined there, but they're not spelled out specifically. They're more broad terms. So this is a very specific resource guideline in a material passport. And again, all of these two documents happen on a product level. When we get to the building level, you could think of with EPDs, like a whole selection of EPDs plus some generic data, give you the data that you need in order to calculate a life cycle assessment on a whole building level. Whereas with the material pass, a whole selection of digital material passports form what we call a building pass. Some people call it a building log. So you have a profile of that building on a building level. And then these two things together, plus other information, for example, energy information and a solid set of project documentation, give you your 21st century building profile. So it's really built up of a lot of different building bricks. And this leads us right into this discussion of buildings as material banks. We have this lovely term that was used in a Horizon 2020 project that ran in the EU from 2016 to 19. It is finished, and there's lots of very nice documentation that has come out of this initiative, this EU-funded project. And the project was called BAMP, Buildings as Material Banks. And essentially, that summarizes very clearly exactly what the project was. It was simply looking at buildings as a way to store our resources, and that this was a vision that was created to utilize existing resources for future constructions, to close the loop, and to address the triple planetary crisis in order to reduce climate change impacts, to reduce pollution, and thereby to reduce health and environmental impacts. The new vision was created to visualize our buildings as these storage banks for resources. And that digitalization plays a very key role in making this a feasible ambition, so that the project looked very specifically at how is it that we can make construction of buildings a reversible process. And in order to do this, we really need to have more data. We need to also think about the way we're making connections in buildings, but on a product level, we need to have some very basic data that addresses these aspects of circularity. And that were this all to happen in an ideal world, if we have the data that we need, if we begin to think about our buildings as reversible design processes, and we have essentially imbued our projects with more value based on this basis, this new data that is essential in order to create value for secondary use. So that said, what's out there today? How far are we in this vision? I'm always very exciting to talk about visions, but perhaps maybe even more interesting is to talk about, well, where are we in achieving it? And there are a lot of different initiatives that are underway, and a lot of things have been established that are in a process. In the States, there is a health product declaration, which is almost, in my eyes, a digitalized product passport, except that we need to have more circularity data in this. And we need to have a better way of linking this data into our BIM models and IFC models. So they have the chemical content. That's working really well with the health product declaration. The circularity aspect needs to follow for this to be a more well-rounded digitalized product passport. The Swedish Byggevarudeklaration is digitalized. There's an e-BVD, the electronic declaration is in existence. It has been for the last many years, actually. And again, this passport is very strong on many aspects of product passport. It could be a little stronger on, for example, things like disassembly, how do you, or separation of the product. Information about that is lacking. But it's very strong on giving information about the chemical side and also on the content of the products. The Netherlands is looking at more an approach to guidelines for how to make passports. So they have a whole roadmap here. And in Denmark, we've been working on an actual passport, trying to take it from the guidelines down to the how is it that what are the actual questions we would ask, and what is it that manufacturers, what is the data that we need from manufacturers that is actually the missing data that we don't have today. The Danish Technical University has issued a very interesting report, came out last year, looking at some of these existing initiatives and then trying to compare them, which ones have chemical content data, which ones address aspects of circularity, which ones have technical performance data about the products, and trying to highlight which of the passports, the existing passports, are more successful in their content and what they're asking of manufacturers. On the building passport level, again, just as a reminder, all of that was on the product level. And when you have a collection of these product passports, you have essentially a building passport or a building log. So you have the building bricks and the data profile on a building level. And it's the building passport that could be quite interesting in terms of identifying whether particular building assets have a value for the future, or have a value or residual value in terms of actually selling parts of the building. And again, emphasizing this buildings as material banks. Does the client, the building owner, actually own a value, and how do they access this value, and how do they sell it in order to get the most out of the asset that they have? You may have heard of this project coming out of the Netherlands called Madaster, and Madaster has a fabulous interface and is essentially a building passport. What we have on the screen here is a building, and it shows what Madaster can do by summarizing what is this building made of. And in this case, we have a building that the data has been put into Madaster, and it crunches through the data of what's in the building, and it spits out that we have a building that on the far left, you can see the totals. It's 30% stone, 6% glass, 2% wood, and this continues with very broad descriptions of materials. So you have plastic and you have concrete, and you have very broad, very generic descriptions. I will say that Madaster is really interesting in terms of its potential. What Madaster is actually missing is the digitalized material passport, so that it could have much more information on a product level. So that when these product passports, which really aren't active today, but are in development, but when they are further along in development, that they would be a huge support to Madaster, because then Madaster can simply draw upon much more data and thereby imbue the projects with much more value, because they have much more information about what is actually in the project. So this is one slide from Madaster. I think I have a second one here that shows Madaster also breaks down in terms of what you have in your facade. And again, we just have these kind of bare bones descriptions. We just have stone, glass, wood. We don't have any information about how accessible is that stone or glass, or what kind of glass it is. Glass can be so many things. You really need many more levels of information here to make this into a very useful building log. And then on the right, you can see the total overview. And again, I just point to the fact that we have a way, and it's digitalized in a very interesting way, and a fabulous interface for a building owner but the output is a little bit limited right now because the input is not so strong. There are other building passports out there, and they all have their particular angle. This one is from Sunderhus, which is a Swedish private company that offers subscriptions to building owners, and their focus is very specifically on hazardous chemical content in building products, and they keep this data on a project level for building owners for forever. They have long subscriptions so that the data that they get on a project level is within their system and accessible. And depending on the agreements with the owners, the project owners can then get information. If, for example, some of the contents of the building are flagged in the future, we don't know what the hazardous chemicals in 10 years may be. So our substances of high concern this year are not the substances of high concern in 10 years, which is why a positive list of content is so informational, is so useful. And Sunderhus then can say, okay, by the way, this particular substance has come on under scrutiny, and we can flag your project in these particular building products, you have an issue. And this is, of course, very useful information. If you think backwards and look at the asbestos catastrophe that we faced in earlier years, were building owners able to get very specific information about, oh, by the way, our data shows that you have these 10 products in your project that are problematic. And this is their location. And this is actually how you access them and take them out of the building. If we had this additional information, this would have supported a lot of processes. And this is the thought for looking towards the future, that this is the kind of information that would be very useful because we don't know what tomorrow's problem substances will be. There's another Swedish digital logbook, which is essentially collecting all of the documentation for the products that are used in the book, in the project, and that is called Byggvarubedömning. So there are a couple different Swedish initiatives on this, and they have a very specific focus on chemical content. So one last passport that I would like to present, and that is the passport that is really the passport of the future. This is the one that is really doing many things in a holistic way, and that is the French Upcyclia cloud passport. And this is really the most effective circularity passport. So this organization has, it's very closely linked to Cradle and is based very closely on Cradle to Cradle data. The information on a product level, and they have about 4,000 different product passports in their system, gives basic information. It gives the composition or what is the content of this, including the list of banned Cradle to Cradle components. It then also has number 3, which is information about the life cycle and the next lives, how it could be upcycled or what the potential for its next reuse is. And it also has environmental, the last one is environmental performance. And the social comes in with the whether it's Cradle to Cradle certified or not, or whether it has a Cradle to Cradle material health certificate. But it also includes the environmental CO2 footprint. And this is all on a product level, but they also offer 3 services. So there's free access to all of this data for anyone who accesses the website. But they offer on a subscription level access to a BIM platform where you can save your project under the Upcyclia cloud, and then link the data passports into your BIM model. And the third, which is extraordinarily interesting, the circular management for building owners and for building management companies. This gives you the status of the building's financial residual value on a daily basis. So based on what products are in your building, what their value is, and what their next life value will be. This is what they offer on a subscription level. And they are beginning to build this part of their system up so that they have more clients who are looking at this building management level. So this is the future, linking the products into the projects on a digital level, so that the owner simply has much more data at their fingertips, and so that it is much better understood how it is that we can actively do a renovation project in a part of a building and then take those materials and pass them along in a closed loop when possible, so that we are supporting not a make, waste, linear development, but the circular usage of building products. So that's what I have, and I'm really very interested in your questions here.
Fantastic, Martha. Thank you so much for this, overview of what's going on in steps towards circularity in the built environment, the need for materials passports, need to understand the material content of buildings, and then the steps towards driving the development of knowledge around those materials so we can actually reuse them. One of the things that I think is that key quote that struck me, and we have a lot of comments that have come in from people around the world, and please, everybody, punch your comments into the comments section. We will pick them up and ask Martha about them. But you, just to start off real quickly, you stated this quote that I thought was very powerful, where you said, "You cannot reuse what you do not know." And a lot of the things that I see is easier to do when you're building the building from scratch. But what about the buildings that already exist? And it makes me think about one of the questions that we have from Carla Gonzalez-Talbas in our section where we talk about existing materials. How do we bridge that gap around the knowledge of the materials that are in pre-existing buildings? Can we imagine that the facility manager goes around cataloging the different materials that are in their buildings? And then how do we reuse those materials?
Yeah, this is really essential, because the initial ideas, and I will say that our passport initiative is about 5 years old now. So our initial idea was really focusing on newly produced. But in the last couple of years, we've acknowledged this has to also be for cataloging and documenting materials that are already in our existing buildings. And how is it that we then integrate this information? Because it's a very different source of this information. We don't have the same kind of knowledge about the materials that we take out of older buildings as we do from materials that come virginally produced from manufacturers. So we need to produce a framework that accommodates the possibility to document what we do know along the we have the historical information that's highly relevant, that needs to be documented. And then as it moves along, these used materials often switch ownership. So each of the owners needs the potential for some reporting of what was done or what was tested or what was recertified with the product. This is all necessary to support this basic data. And it's also very important just to acknowledge that we're going to be working with uneven data backgrounds for the two different reused materials as well as new materials. So even knowing that it's reused is very essential, so that you know, okay, well, my assumptions on how much I can know about it are reduced.
Okay, thanks for that. And that leads to this question about data and data veracity, what we can know. And one of our comments from Martin Ruppel was saying that this sounds like blockchain or distributed ledger technologies could be a base for such a passport. What are the technologies that are supporting this passport?
Well, blockchain is really highly relevant. Blockchain is relevant for, it's relevant in multiple phases of this project. Also, I've been looking at it for manufacturers to look downstream to see how they can begin to understand what's in their product. So the information along the downstream can be collected, and so that basic downstream information is also imbued in and collected in. And I think blockchain could be very useful here. And I think that there are a lot of other potentials for blockchain. I will say that I come at this from an architect and from the designer perspective and from the understanding of what kinds of information we need to know, and not from the digital side. So I'm not a blockchain expert. I just have my partner saying, yes, this could be really useful. So I'm sorry for the half answer there, but I acknowledge that this is really an important part of the development and
But
has
this
really
is
good potential.
right. And you were speaking, particularly as we start talking about the longitudinal aspects of buildings as we transfer ownership of the asset from one person to the other. And you were also talking about that residual value. So the blockchain and things like that,
Yes,
and that digital lifespan, or that lifespan of that data is absolutely essential to this.
correct. Yeah.
Okay. Fantastic. Now, one thing that comes up is we have a number of different initiatives. The EU has done some investments in or investigations about potential frameworks. But one of our participants, Kevin Pennell, is asking, what about the next steps beyond just the labels and the different types of kind of declarations? Is there some sort of national body that is determining what is acceptable? And is the data that you're actually reporting, is that accurate? And what happens if you're misreporting the data on your declarations? Which, kind of leads into that discussion we were having on carbon reporting requirements that are emerging in different jurisdictions.
Yes, all really good questions and all essential pieces that have to be addressed. I will say that the EU right now has put out to tender under the digital product passport tender the call for prototype passports for 3 different sectors. So to see the potential for developing in electronics and with batteries, and with a third sector that may be buildings and construction, but may also be textiles or something else. But this is where the EU is right now. So they're just putting these out for a digital prototype development to see how this could look, what could be addressed, how this could be digitalized. And that's essentially to say the EU is also in an infancy state with this. And some of the questions that you're asking point to implementation. Like, how is it that, for example, third-party verification of the passports on a product level, how will that be implemented? Or who will be responsible for that? All of these are questions that right now are questions. I think that one of the things that is quite essential in this process is to develop material passport standards, which we are working on or will be working on. I should not get ahead of myself, but there is a subcommittee set up under SEN in the EU to look very specifically, how do we establish standards for circularity? And hopefully one of these standards will be the material passport. And we're working on this, but it's slow with the standards work. And these are very critical questions to identify ownership of the data, ownership of the passports, how they'll be updated. Is there a national filter? How can this be developed so that it reflects the existing legislation that's already in place with the construction product regulation in Europe, so that it aligns with the existing way that construction products are treated under the single market system in the EU.
Yeah, fantastic. And I think that this also speaks to one of the questions that we have from Melanie Mayo Rogers, who's asking, can you speak to the challenges of tracking embodied carbon with furniture and equipment versus buildings materials since they are evaluated differently?
That's an interesting one, because if you're talking about tracking of embodied carbon, I think that the information about embodied carbon is really important when you're making the initial selection for a building project, and that it's less important to track it through its life. So I'm a little bit confused about the tracking, and maybe I've misunderstood the question. But this is quite valuable information when you initially are deciding, I would like to have a lower carbon impact when I make this building. So I'm going to be choosing reused products that at the moment come in with a zero carbon profile. That may change, but at the moment, anything that is a reused product, plus the processes that are needed for cleaning or rinsing, those count as positive, or those count as an impact. But essentially, you get a bit of a freebie by reusing the product. So this is very useful in the selection process, but less useful if you're doing a renovation in 25 years. Your carbon information about the products is not so relevant. You're taking it and you're sending it along in a system. So that about the tracking. But if I just address the last part of your question, challenges between furniture versus building materials, I actually see that as being really quite similar, because you're looking at taking furniture in, and if this is newly produced furniture, it has a carbon impact that you should be assessing, and you should have the data for that. And if you're taking in a new building material, wall, ceiling, floor, this is also a new product where you should have the data. If they're reused, then you also should have the data for that, in terms of either you don't have, it's 100% reuse, or it's some reuse that has gone through extra processes where there has been energy used to do cleaning or upcycling. And that would have an impact. But ultimately, we need to refer to the environmental product declaration. And if furniture doesn't have an environmental product declaration, I'm not seeing very many of those for furniture, then we're at a loss as a designer. So that's the biggest challenge for us, is that we don't have the data for furniture. We have much more data for building products.
Okay, well, we'll get into the embodied carbon discussion when we talk with George and Spencer on the 17th of May. So thank you for that. One question, I think we have time for just one last one before we have to wrap up. And this question relates to, we're talking about the unfolding of an entirely new space and the way that we manage our buildings and design new buildings. And you work in an architectural firm, you work in design, you're the head of materials. What do you think that you need from facility managers so we can close that gap that, facility managers and architects often, kind of snipe at each other about their not good linkages in the ways that they work together. So what do facility managers need in this journey towards circularity that could help, bring us closer to the goal?
Well, I'm actually going to just flip that and say, what do architects need? And I think that from facility managers, and I think that we've all heard this. It's been a big initiative of LEED, certified buildings, get the facility managers into the room much, much, much earlier. And I just echo this, because even though it's part of LEED, I still think that it isn't happening to the degree that we could benefit from it happening. If it were to increase, it would benefit our projects. On a very specific level, I will say that I think that you've heard me say multiple times now, these passports are in development. We're working on developing standards. We're working on developing the passports. We don't have a passport out there that is the answer yet. And in that process, in this development, I say that we need to have a really strong dialogue with facility managers to make certain that the data that we're asking for in the passports is actually the data that is useful. And the processes that we envision for accessing material passports on through a building passport is actually feasible and implementable from a facility manager's side. I think that these are all points that are actively part of the project that we're working on now, trying to address the development of the material passports. This is something that we have focus on, but it's not a completed process, and it's something that we're very aware of, that this feedback is and this interaction is necessary in order to not develop something that's not usable. That would be a failure.
Okay. And so there's opportunities for facility managers to engage and shape the future direction of materials passports and the concepts of buildings as materials banks.
Right. And also, we have ideas about how do we, on a data level, interface with the systems that facility management uses to manage and monitor buildings. And this, of course, has to be a seamless interface with what we're developing, so that what we're working on can be implemented and be effective.
Fantastic. Martha, I want to thank you so much for taking the time to share your insights and expertise with all of us. We just had the opportunity to speak with Martha Lewis, head of materials at Henning Larsen architecture firm. As we can see, she's got her finger on the beat and the pulse of, future directions in circularity in the built environment, at the heart of European activities on buildings as materials banks, development of new standards in the Nordic region and in Denmark and everywhere else. She's one of the experts that we've had to participate in the FM Symposium at Facility Fusion. And next week, we're having the opportunity to hear from Kevin Powell, Director of Emerging Technologies in the Green Proving Ground at the U.S. General Service Administration on emerging technologies at the same time, and also save the date for May 17th for net zero operations, where we talk about embodied carbon and how to measure it and audit it, with George Sullivan from Net Zero Analysis and Spencer Robinson, professor at Central Michigan University. Thank you so much, Martha. Thank you, everybody, for participating from around the world. And we look forward to speaking to you all again next week at the same time. I'm looking forward to seeing you then. Thank you so much for today.